In this video, I'm going to show you how the ML agent training loop works and how you can train your own reinforcement learning agent. I'm going to use this vacuum robot as an example, but I'm not going to go into too much detail about how this robot works. I don't think that's helpful to you. I think you should just focus on the concepts that I'm trying to show you. In order to turn our robot into an AI agent, we need to add a couple of ML agent components. You can see that the robot is simply a cylinder with a red cube. So nothing special here. The first component that we need to add from the ML agent library is the behavior parameters. If you click on add component and just type behavior, this is the one that you need to add. I already got one here. After adding it, give the behavior a name. The next thing that we need to set is the observation size. Observation is basically what the AI sees. Let me start the scene and then pause it. Okay, so I have 16 sensors coming out of the robot. I'm basically using raycasting to send out 16 sensors, and when they hit a star, it will calculate the distance between the robot and the star. And 16 is just arbitrary. It seems enough to sense the robot's surrounding. You can increase or decrease that number. So since there are going to be 16 distances, our observation is set to 16. For the actions that the robot can take, the robot can either move forward or it can turn. So there are two branches of action. The robot can either move forward or rotate, and it can do either one of those moves independently or in conjunction. So we have two branches of action, with branch 0 being the forward movement. The robot can either choose to not move or move forward. So the size of branch 0 is 2. Branch 1 is rotation. The robot can either not rotate, rotate left, or rotate right. So the size of branch 1 is 3. Okay, those are the only things we need to set for now. The next thing that we need is to add a script to the agent. So in your project, in your script folder, create a new script and then just drag the script onto the robot to attach it. I'm going to double click on the script to open it up. We need to import Unity ML agents and make sure that the class inherits from mlagents.agent. When we inherit from the agent class, we need to implement a couple of functions, and I have it listed here. We'll come back to this later. The last thing that we need to add to the robot is a decision requester. So add component, decision requester. We don't have to change anything here. We can just use the default. The decision requester is for the agent to request an action from the AI model. This 5 here means every 5 physics update. 5 physics update means 5 calls to Unity's fixed update function. Every 5 physics steps get a new action from the AI model. Now, why 5? In Unity, the fixed update function is called every 0.02 seconds. So 5 times 0.02 is 0.1. That means every 10th of a second, we're going to request for a new action from the AI model. If we try to request too frequently, let's say we set this to 1, so every 0.02 seconds, we get a new action. The robot doesn't even have time to actually perform that action. So 5 is enough for an agent that doesn't move too fast. If your agent moves very fast, then maybe you want to request a new action much quicker. Now let's jump into the script and see what we need to implement. We talked about having to override a bunch of ML agent functions. Let me show you a diagram of the sequence of events. The first function that gets called is the initialize function, and it's going to be called only one time. Obviously, in the initialize function, we initialize stuff. Here I'm instantiating the variables that I need to keep track of the distance between the robot and the stars that it senses around itself. The next function that gets called is onEpisodeBegin. After initializing the environment, we start training, and on the start of each episode, we should be putting the stars back into place and dropping the robot into its initial location. Here I'm using the game manager to reset the game, and it basically does what I described. Let's jump over there. It's looping through all the stars and destroying it and then recreating it. Okay, so these are just some basic for loops and calculating distances where the stars should be and just dropping the stars there. At the beginning of the episode, we need to collect a set of observations to know our current state. And this is done only on the very first run. I'll explain that in a moment. Collect observations. Here we're simply adding to the robot sensor array, calling the add observation function, which takes in a list, and we have our list of distances from the stars. And the distances, it's being calculated in every frame. Unity's update function, and it's calling the detect surrounding function, which is just right below. And this is just more math and using sphere casting to detect the stars, and if it has a hit on a star, it's calculating the distance. And this is just drawing out the sphere. Drawing this is purely for visualization so that I can see what's going on. Doesn't really add to the AI training. After collecting an observation, we need the robot to perform an action, which goes to the onActionReceive function. Now there are three paths. The first one is heuristic, which is manual actions. So in the heuristic function, I'm basically detecting what keys are being pressed. If the up key is pressed, I'm setting my branch 0 to the action of 1. So if I have branch 0 set to 0, it basically says don't move forward. 1 means move forward. Branch 1 for rotation at 0 means no rotation. And if it detects the arrow key, set branch 1 to 1 to move left. If it detects the right arrow, set it to 2. So this is consistent with the branches that we set up here. Now, why do I need to implement this heuristic function? It's purely for testing. So when you first set up the robot, you want to be able to make sure the movement is correct. So you want to program this function so that you can check the actions straight from your keyboard. Now let's go back to the scene. I stopped the previous run. I come over here to the behavior parameters. Under behavior type, change this to heuristic only. Now, when I click on play, it should call the heuristic function. Let's see if it does or not. Okay, so the robot's not moving. I'm pushing on some arrow keys, and I am controlling the robot myself. And again, this is purely for testing. Now I'm gonna stop the scene. It calls the heuristic function to get an action from the keyboard, and then it passes it into the onActionReceive function. Coming down to onActionReceive. Notice that in the heuristic function, we modify the action output. This directly comes into here, onActionReceive. And using the branches, using branch 0 and branch 1, we get the values here into these variables. For movement, if it's 1, that means we want to move forward. We do the basic Unity movement calculation. And the same thing for rotation. We do the basic rotating left and rotating right. In this function, we did the movement and rotation calculation. Where does it actually perform the movement? That is being done by the fix update function. This is where I'm actually performing the movement on the calculation that was done above. So underscore movement is a class variable. This was saved previously. Same as rotation. We're just performing the movement inside the fix update function. Let's complete this flow before going back to the branches. After the agent perform an action, we need to give the agent some feedback in the form of rewards. And rewards can be called one or more times. It's not a function that we override. It's a function that we called from anywhere within our code. So we're actually calling add reward inside the onActionReceived function. Here we're adding a small penalty to encourage the agent to keep moving and exploring instead of standing around. There are other places that calls the add reward function. Here in my collectible class, all these stars, they're attached to the collectible script. Let me find that prefab here. And it's this guy. You can see that my collectible.cs file is attached to the stars. In the onTriggerEnter event, this is the collision detection event. It's comparing to see if I'm hitting the robot, which I put a tag of player on there. So if it's colliding with the robot, destroy itself, play some particle effect, and then here we're calling the add reward function of the vacuum and giving it a reward of 1 for collecting the star. Here you can see that the add reward function should be called in various places wherever it makes sense to give the agent feedback. After the robot takes an action, we want to know what the feedbacks are, and then we want to know what the current state is. We want to capture the new state or what the robot sees so that we can decide on the next action. Now let's say we collected all the stars. This would trigger a end episode event. Let's see where that is. This is being done in my game manager script. So the game manager basically manages setting up the scene and all the various logistics. Let's see where we call end episode. I folded all the functions to make it easier to see. Let's see where end episode is called. In the update function, I'm constantly updating the stats on the bottom here. Also, I'm detecting if all the collectibles or stars have been destroyed. So when the count is 0, I call the endGame function. Endgame is just right down here. In the endGame function, I'm giving the agent a reward of 100 for being able to collect all the stars before time runs out. And then I'm calling the end episode function, and ML agent will do some calculations to wrap up this episode. After this episode ends, we collect another set of observations to see what the current state is, and then we're calling the onEpisodeBegin again. And since we already collected observations at the end of the episode, we don't call this collect observation again. We skip directly to this branch. We had talked about using the heuristic branch only for testing to make sure that your robot is interacting with the environment correctly. Now to do actual training, we're going to set the behavior type back to default. We're going to use ML Agent's Python trainer to do the training. So let's see how we can do this. I'm going to open a Anaconda prompt. And then I'm going to activate my environment. This is where I installed ML Agents. So if you don't know what I'm talking about, in the ML Agent installation, you would use Conda to create an environment. They're naming it ML Agents. I name it ML Agents _env. You have your Python version, and then you activate this environment. After you activate this Conda environment, you go and do a pip install ML Agents. So your ML agents end up being installed in this environment, and I am just activating this environment. Now let me go to my project folder. Oops. Let me show you what my actual folder looks like. So let me go up one level. This is my project folder. I have a configuration file here. This configuration file is one of the samples from the ML Agents library. This is how we configure the training parameters. So right here, this is the name of our behavior parameter, vacuum behavior. Back at the robot vacuum, remember that under the behavior parameter, we gave the behavior a name. This is the name that goes into the configuration. So we're configuring this agent right here. We want to train using the PPO algorithm. I have a very detailed walkthrough of PPO if you are interested. I'll put a link in the description. The max steps parameter defines how many steps or actions you want to train the agent on. So here I set it to 15 million. So depending on the complexity of your environment, this is where you can set how many millions of steps you want to train your agent. Everything else you can pretty much leave as default. Now let's kick off the training. Coming back to my Anaconda prompt. To start the training, I want to run the command ml agents-learn, pass in the config.yaml file, make sure your path is correct. For the run ID, you can name it whatever you want. ML agent is going to create a results folder called vacuum1 for me, and then it's going to put all the training results in there. If this is your first time running this command, you don't need this -- resume. But if you stop the training and you want to resume it, you can pass in -- resume. Since I did, I'm going to keep this in, and then I'm just going to hit enter. Previous data not found. Okay, looks like I did not run it with that name before. Let me take a look. Go up to my project and go into the folder that I want to start training from. You can actually start training from any folder. And since this is the folder I'm starting training from, it created a results folder for me. Looks like the one that I was training is called vacuum2. So let me resume my vacuum2 training. Once you see that it is listening on a certain port, it's telling me to press the play button in the Unity editor. Before I do that, make sure that the behavior type is set back to default, and then click the play button. Now training is happening right now. Let's go back to the diagram. So I changed my behavior type back to default. I started the trainer, and training is happening right now. So instead of getting an action from manual like before, this is actually getting an action from the model that's being trained right now. Obviously, at the beginning of training, the neural network model doesn't really know anything, so it's just generating random actions. But as training goes on, the model is going to get better and better. Since I'm resuming training, I've already trained this model probably millions of times, and you can see that the AI is already picking up the stars pretty well. After a certain number of steps, it's going to save the intermediate model. Now, while it's training, let's go back to the diagram. So what is actually happening in this loop? Basically, we're collecting experiences for the PPO algorithm. And then after collecting enough experience, it's going to update the neural network or AI model. And that's actually defined by the buffer size, which is right here. Basically, about every 10,000 steps or 10,000 actions, it's going to do an update to the AI model. And then it's going to use this model for collecting experience over the next 10,000 steps. And then it's going to update again, and it keeps repeating. So what does the experience looks like? The current state is the initial observation, the action that was taken, here. The reward is the sum of all the calls to the add reward during this cycle. And then the new state, we come back here, we collect observation again. That becomes the new state. And then it's done indicates whether we reach end episode or not. So if we just went this route, it's done is going to be false. But if we clear all the stars and the episode ends, then it's going to call end episode, and it's done is going to be true. Okay, so it constantly collect a whole bunch of experiences and use that to update the AI model. Now let's say training is done and we have a AI model. We can follow this path, set the behavior type to inference. Inference means to use the AI model to make decisions. I'm going to stop the training here. If we had trained enough times, the trainer would have written the model into the results folder. Let me go check. The model is going to have a .onnx extension. So this is the AI model. Now let's see how to put it back into Unity. So I was in the assets folder. Let me find my model. Under the results folder, here's my vacuum 2, and this is my model. Now let me click on my robot. I already point to a certain model. Let me replace that. And then I'm going to set my behavior to inference only. And now if I push play, let me make sure the trainer is done. So the trainer is going to stop trying to train after a while. It's going to throw some errors, but it doesn't matter. And now we're pointing to the AI model. We wanted to do inference only. It's going to use this model to make decisions. We can press play and see what happens. Okay, so it's using the AI model to make decisions. Looks like it's not bad. So obviously you would keep track of the rewards and see what the best reward is or the best time is. That way you can assess the performance of the model. Now, if you're not happy with the performance, you can always come back and make sure you run the command with --resume. That's going to resume training. Once it starts training, of course, you push play. Before you do that, make sure you switch back to default. Once it trains and you have a new model, make sure the model that's being pointed here is the one that's the most up to date. And then make sure the behavior type is inference, and then you can run this again. All right, so we have gone through the whole ML agent training loop. If you have any questions, please drop it into the comments. And make sure to like the video and subscribe if this was helpful to you.